The circuit diagram below shows a cell of EMF 18 volt. Okay, you have EMF 18 volt, this one, and internal resistance of 1 ohm. So this battery has internal resistor connected in series with a resistor of resistance 2 ohm. So you have a resistance here, and a uniform metal wire AB of total resistance 6 ohm. Oh, so AB is a resistant wire. It's not a normal wire, but it's a wire with resistance. So this whole thing, it has resistance 6 ohm. Okay, so second cell of EMF 4 volt. Okay, here I've got another battery and internal resistance 1 ohm. Okay, connected across the wire at A and C. And C is halfway the wire. Oh, the current direction shown in the circuit below. Determine the current I1, I2 and I3. I1, I2, I3. Okay, C is halfway. So that means AB is cut into 2 halves. Okay, cut into 2 halves. So we can say here got resistance, here got another resistance. So and then since this is the total resistance, so since the total resistance AB is 6 ohm, so divide into 2, we can say this resistance here is 3 ohm, this one also 3 ohm. So something like this. Yeah, something like this. So the resistance AB is divided into RAC and RCB. RAC, RCB. So 3 ohm, 3 ohm. Okay. So now the question asks for finding the I1, I2, I3 current. Okay. So seems like this question is not a potentiometer question, but it's more a Kirchhoff rule question. Okay. So first of all, you need to redraw the diagram. Please redraw the diagram, and so that you can easily identify. And then you must label the EMF from negative to positive, E1, negative to positive, E2, and then the current need to draw at all the resistor. Like for example, I1 passes through 1 ohm, 2 ohm, and then entering junction A and then exiting junction C. So and then passes through RCB. Just now the resistance AB divide into 2, RAC which is 3 ohm, RCB which is also 3 ohm. Okay, you see, the current actually is like that. Current, let's say start from here, current come up from here, or we can start from here. So you see I1 and I3 branches out like that, and then going, and then meet at A, combine, become I2, and then I2 break into I1 and I3, and then meet again at I2, meet again at point A, combine, become I2, and I2 break into I1 and I3, circle, and then I1 and I3 combine at A, become I2, and then break into I1 and I3. Okay, understand? Alright, so redraw the diagram. Please label the current near the resistor, okay, near the junction. Then resistance AB is 6 ohm, C is halfway, so RAC is 3 ohm, RCB is 3 ohm. Now apply first law and second law. First law, current in, current out, we choose junction A. Current in is I1 and I3 combine, become I2. Alright, and then second law is loop 1 and loop 2. Loop 1, total E equal to total IR. So loop 1, I choose anti-clockwise, because I try to follow the current also anti-clockwise. so that we will get more positive values. So okay, let's look at loop 1. So E1 is same direction with the loop. So E1, you see, okay, so the E1 is same direction with the loop. So E1 is positive, yeah, positive. And then let's look at resistance AC. AC, the current passes through I2. Yeah, I2 multiply RAC, and then I2 is same direction with the loop, so positive. And then RCB current is I1 is same direction with the loop, so also positive. Okay. And then the 2 ohm current passes through is I1 is same direction with the loop, so also positive. Okay. And then 1 ohm internal resistance current passes through is I1 is same direction with the loop, so also positive. So we get formula, new formula 6 equal to I2 plus 2I1. Yeah. New formula. Then let's look at loop 2. Yeah? Loop 2 is this one. Loop 2 is clockwise. Okay. So total E equal to total IR. So what is the EMF? Okay, EMF, you have the E2. E2 now is same direction with the loop. Yeah, I choose clockwise, this one. So E2 is same direction with the loop. So E2 forward is positive. Positive, yeah. Positive E2. Now, how about the others? So you have resistor. You have 2 resistor here. So let's look at RAC. RAC is I2. I2 same direction with the loop. Same direction. So also positive. Also positive I2 RAC. Then again 1 ohm current passes through is I3. I3 is same direction with the loop. Same direction. So also positive. Positive I31. So now you have new formulas. 4 equal to 3 I2 plus I3. Okay, so you have 3 formulas now. 1, 2, 3. Okay, so to solve to get the value of I1, I2, I3, so rearrange the formula or become I1, I2, I3, I1, I2, I3, 1, 2, 3. Yeah. And equation 2 just now don't have I3, you must put 0 I3. Equation 3 don't have I1, you must put 0 I1. Okay. So then you just press calculator, scientific calculator, then you can get the I1, I2, I3. Okay. This one I3 means got negative. This one got negative current means the actual current direction is opposite to the current direction drawn. Okay.